The chapter is coordinate geometry for standard 10 and this is part 1. So you are aware of plotting the points, coordinates in a Cartesian plane. Now here we are going to find the distance. The first part of this chapter is finding the distance between any two points. So let the points be P and Q and let the coordinates be x1 and y1 and this coordinate of Q is x2 and y2. So the distance between the two can be found using this formula. PQ is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Either you can do x1 minus x2 or x2 minus x1. That doesn't make any difference because we are doing square. So the difference between the x coordinate, the square of the difference between the x coordinates plus square of the difference between the y coordinate. So x2 minus x1 the whole square plus y2 minus y1 the whole square. If you do the root, you will get the distance PQ. So let's do one problem. You will be able to understand it much better. So the distance, find the distance between the points. So this is x1 y1, x2 y2. So distance, so let this be P minus 6 7 and Q minus 1 5. So PQ is equal to root of minus 6 minus 1 the whole squared plus 7 minus 5 the whole squared. So this will become plus, so 5 25, so it is root of 25 plus 4, so it is equal to root 29 units. Here now prove that the points are vertices of a square. So here to prove the points are, now we have to find in a square, you know, all the sides are equal and the diagonals are equal. So we have to find the distance of length of all the sides. So AB is equal to, so when you prove this, it's better you draw a figure like this, plot the points, then it will be very easy to find the value. So AB is equal to 1 minus 4 is 3 minus 3, so 9 plus 7 minus 2 5 25. So it is root 34. So BC is equal to 4 minus 1 is 525, 2 minus 1, so plus 3, so 9 is equal to root 34. Just substitute in this formula, you will get it. Now CD is equal to, again, minus 4 minus 1, minus 4 minus 1, so it is 3 minus 3, so it is 9, 4 minus 1, so it is 525. Now AD is equal to root of, again minus 4 minus 1 is minus 5, so 25 plus 4 minus 7 is minus 3, 9 is equal to root 34. Now you got all the sides are equal. Now here, to prove it is a square, you also have to, if all the sides are equal, it can be also a rhombus. But here you have to prove a square. So the property of a square is the diagonals are also, diagonals of a square are equal. So we have to find AC. So AC is equal to 1 minus 1 is 2. So it is 4 plus 7 minus 1, 8, 64. It is root 68. BD is equal to root of 4 minus 4 is 8, 64 plus 4 minus 2 is 2, 2 plus 2, 4. It is 68. So you got AC equal to BD. So the diagonals are equal. Therefore, it is a ABCD is a square. So, to prove a quadrilateral as a parallelogram, so the previous problem we did how to prove it is a square. So, suppose you have to prove it is a parallelogram, A, B, C, D are the 4 vertices. So, if in a parallelogram, if you are able to prove AB is equal to CD and BC equal to AD, then you can say it is a parallelogram. So, the square just now we did. Now, coming to rhombus, you have to prove all the sides are equal and the diagonals are not equal. If the diagonals are equal, then it becomes square. If the diagonals are not, all the sides are equal. Here, the sides diagonals are equal, then it is a square. The diagonals are not equal, then it is a rhombus. Now, for rectangle, it is similar to parallelogram. Opposite sides are equal, and here diagonals are also equal in a rectangle. So, diagonals AC equal to BD also has to be proved. Then you can say it is a rectangle. Similarly, for a kite, suppose so in a kite the adjacent sides are equal. So, these two sides are equal, these two sides are equal. So, you have to prove it in such a way. Suppose AD, A, B, C, D. So, AD equal to CD, AB equal to BC, or you can prove AD equal to AB and CD equal to BC. If you have to prove these two are equal and these two are equal, then it forms a kite. Now, to prove it is a triangle, so equilateral triangle means you have to prove all the 3 sides are equal, then you can say it is an equilateral triangle. For an isosceles triangle, you have to simply prove the 2 sides are equal. Any 2 sides are equal, then it is an isosceles triangle. For right triangle, you have to find all the 3 sides and then use the Pythagoras theorem and prove AB squared plus BC squared is equal to AC squared, then it becomes a right triangle. To prove it is an isosceles right triangle, you have to prove the 2 sides are equal and the third side will be the hypotenuse then, and you will have AB squared plus BC squared equal to AC squared. Now, to prove that the vertices cannot form a triangle or forms a triangle, so we have learned in smaller classes the vertices to form a triangle, or considering the length of the sides, sum of 2 sides has to be always greater than the third side. You cannot even if it is equal also, you cannot form a triangle. It has to be always greater than the third side. Sum of any 2 sides has to be greater than the third side. So, you can try out this, and then if it is not satisfied, then it cannot form a triangle. So, you have to see that if all the three conditions are satisfied. Find the value of A when the distance between the points 3A and 4, 1 is root 10. So, the distance is given. Now, we have to find the y coordinate of this point. So, using the distance formula, distance is equal to root of 3 minus 4 the whole squared plus A minus 1 the whole squared is equal to root 10. So, this is 3 minus 4 is 1 minus 1. So, 1 root of 1 plus this is A squared plus 1 minus 2A is equal to root 10. Now, we can squaring it, the root will be removed. So, this will become A squared minus 2A plus 2 is equal to 10. So, this is A squared minus 2A minus 8 is equal to 0. Now, we have to find the value of a. Now it is a quadratic equation. So 8, 4 into 2, you can do with splitting of middle terms. So it is a minus 4a plus 2a minus 8 is equal to 0. So a into, sorry, a squared, a into a minus 4 plus 2 into a minus 4 equal to 0. So this is a plus 2 into a minus 4 equal to 0. So the value of a is equal to minus 2 or 4. So you have two values, a is equal to minus 2 or 4. For both the values your distance will be root 10. Now prove that the points are collinear. So here, to prove if the points are collinear, the collinear points means all the points lie on the same line. So AB, if you are able to prove AB plus BC equal to AC, then this you can say the points are collinear. So we will do some problem related to that. So here the points are given here. So now we will prove AB. We will find the length of AB is equal to root of 4 plus 4 is equal to 8, root 8. BC is equal to, again 2 into 0 minus 2 is 4 plus 1 minus 3 is 4. So 16 is equal to root 20. So this can be written as 4 into 2. So 2 root 2. So here it will be 2 root 5. And AC is equal to 4 plus 5 minus 1 is 4, 5, sorry, this is 16. 16, so this is root 20. Root 20, this 2 root 5. Now AC is root of minus 2 is 416. 5 minus 3 is 864. So this is root 80. AC is 216. 5 minus 3 8. So this is equal to, now AB plus 80 can be written as 40 into 2. So it still can be written as 4 is 20 into 2 into 2, still can be written as 5 into 4 into 4. So this is equal to 4 root 5. Now AB plus AC is equal to 2 root 5 plus 2 root 5 is equal to 4 root 5, and AC is also equal to 4 root 5. So from this you can say AB plus BC is equal to AC. Therefore A, B, C are collinear. Hope you are clear with this distance formula. See you all with some more problems using distance formula in my next video. Bye for now.